There are three main states of matter: solid, liquid, and gas. There's also something called plasma. Plasma is like a liquid or a gas. It's just that some of the electrons have been ripped off. You see that, for example, in a so-called neon sign. Don't put any more effort into thinking about it than that. But for regular matter, where the electrons are happily connected to the atoms, we have solids, liquids, and gases. Now, solids, well, stapler. A stapler is solid, right? In a solid, the atoms aren't doing much. They're kind of low energy. You know, think about yourself getting out of bed in the morning. Oh, I gotta move. You move really slowly. Okay? So the atoms in the stapler are moving very slowly. They're just sort of vibrating in place a little bit, right? Sort of how you feel when you've had that first cup of coffee in the morning. You feel like your atoms are vibrating, right? But solids don't do much. I mean, they keep the same shape. They keep the same volume, okay? They don't do very much. The bonds between the particles in here are really strong. The atoms are close together. They're not doing much. Liquids are a little bit more fun. In liquids, you know that if you pour a liquid from one container to another, liquids change shape very easily, right? If I had a glass of water, the water would conform to the shape of the glass. But if I poured out the water, it would easily conform to the shape of the tabletop, and that would be a mess, so I'm not going to do that experiment for you, okay? You've kind of all done that when you've accidentally spilled over a glass of milk or something. In a liquid, the bonds between the atoms are not as strong, which means that the atoms can move more. They can flow. They can slide by each other. And the atoms take that freedom and they're moving a bit faster. So a liquid does not have a particular shape. It does, however, have a particular volume. So you can pour your Diet Coke from the can into a glass of a different shape, and the Diet Coke will conform to the shape of the glass. But if you try to pour a can of Diet Coke into a shot glass, it doesn't work so well because the volumes are different. So liquids can change their shape easily, not going to change their volume. Gas, on the other hand, gas is a big old party, okay? Gas really is a party, woohoo, okay? The particles, very weak bonds between them. They're moving very fast. They're moving in random directions, very weak bonds, right? They're just like doing their own thing, okay? The oxygen molecules in the air right now are doing anything. I'm swatting them around. They're moving around. They don't care. Okay? Gas can not only change shape, but can change volume. And you certainly know that when you try to put air in the tires of your car, right? You can change the volume. You can see your tire getting higher, right? So gas, you can compress a gas, you can expand a gas. It can change its volume, no problem, as well as change its shape, right? So solid, low energy particles, not doing much, right? Liquid, a little bit more fun. Gas, woohoo, party time. So think of it in terms of how close together the particles are, how fast they're moving, and how much freedom they have.